discuss about that Ohm's law. So Ohm's law is nothing but simply we can say that V by I is a constant. We want to show that V by I is a constant. So in previous classes we already discussed what is V, what is I. So V is nothing but it is a potential difference across the conductors, and as well as the I is nothing but it is a electric current passing through a conductor. So V by I is equals to constant. We want to show this is the aim of the Ohm's law. Then we'll go for the activity and we can go for identification what is V, what is I. So first of all, the potential, that is what is the theme of the potential and I relationship. So V is directly proportional to the current passing through the conductor, hence V is proportional to I. So now in a definition purpose you can go for it. Any potential difference across the conductor is directly proportional to the current carrying or current passing through the conductor. The potential difference across the conductor is directly proportional to the current passing through the conductor. So if I remove a proportionality, then V is equals to, now if I am going to remove a proportionality, V is equals to R into I. R is nothing but it is a proportionality constant. R's another name is nothing but it is a resistance. So the resistance R is equals to is a constant. So constant for each and every conductor, each and every conductor the resistance values are constant. So one more definition is also there for the resistance. The obstruction of flow of current is called as a resistance. So it is right to control the flow of charges passing through a conductor. Then, so in this equation, V is equals to R into I. Then V by I is equals to R. Then what we call that? This is called as a Ohm's law. So V by I is equals to R. So if you know that, if you know current value or potential value in this equation, the ratio between the voltage and amperes, means the ratio between the potential differences and current values, we can easily find out how much of resistance of the particular conductor, we can easily to identify. Then, so R will be calibrated in a ohms. The R is a ohms, like is a ohms. That's why the units of the R value is a ohm. So the symbol is like this. So ohm is equals to 1 ohm is equals to 1 volt per ampere. Is nothing but it is a ohms or otherwise volt per ampere. So these are the units of the particular resistance. So ohmic conductors are there, non-ohmic conductors also there. So what is meant by ohmic conductors and non-ohmic conductors? Means which obeys the Ohm's law is called as a ohmic conductors, which does not obeys the Ohm's law is called as a non-ohmic conductors. Simply we can say that which is ready to follow the Ohm's law is said to be the ohmic conductors. Non-ohmic conductors means which does not allow the Ohm's law, it is not to follow. So what is the Ohm's law will explain that each and every conductor contains their unique resistance value. For example, if I am going to take as a iron is having proper resistance, so it does not change. That's why it is a constant. And resistance value, if you apply any voltage or any current on it, the resistance value will be changed. So that's why there is a 1 ohm is equals to volt per amperes are there. So here there is a ohmic conductors are containing unique or uniform. Okay. So if I am going to take as a VI graph, there is a potential difference are taking on a x-axis and current values are going to take as a y-axis. If I am going to apply the Ohm's law in a particular ohmic conductors which follows the Ohm's law, that conductors are containing these kind of unique or uniform. Okay. So this is a passing through the particular origin. It's nothing but it's a uniform. It won't be changed. So ohmic conductors. For example, non-ohmic conductors are there, which is not following a Ohm's law. So that structure is going to appear as in like this. See, it is not a linear. It is nothing but it is not a constant. So it is a V is on x-axis, I is on a y-axis. It is not linear. It is ready to change on depending on the situation. So this is a Ohm's law. This is a ohmic conductors. This is a non-ohmic conductors graphs. A graph can explain that ohmic and non-ohmic conductors. Limitations of Ohm's law is there. Limitations of Ohm's law is nothing but so which objects are ready to follow the Ohms and which is not following the Ohm's law, and what is the defects in this Ohm's law. We can easy to identify. So Ohm's law is fail to explain the gaseous conductors. What is that? So the potential difference is directly proportional to the current passing through the conductor. That is the main concept of formula of the Ohm's law. So Ohm's law failed to explain the gaseous conductors. It is right to applicable to different type of conductors, but gaseous conductors are failed, and semiconductors also, gaseous conductors and as semiconductors also, it is a failure. The first one is a gaseous conductor. So it failed to explain the gaseous conductors, and as well as the next one is a semiconductors. So it failed to explain the Ohm's law in a semiconductors. So these are the two drawbacks of the Ohm's law. So after completion of the Ohm's law, so what is the resistance and the resistor and so resistivity? For example, the flow of obstruction, if any current is passing through a conductor. For example, if I am going to take this is a conductor. So this is a conductor. We are going to consider as a one cross sectional area. The charges are moving. For example, so moving charges are electrons and fixed charges are protons, or otherwise this is a positive ions. We can call as a positive ion. Sometimes we can call it is a lattice. Lattice is nothing but in a fixed area. It should be so up here. So no movement in a particular lattice ions is a fixed area. So when the electrons are ready to transfer, or electrons are ready to move in a forward direction, for example, these are the electrons are ready to move forward direction, ready to hit the or collide with a positive lattice ions. Then lattice ions are ready to vibrate. So with the electrons collisions. Then electrons are ready to come back again. It is ready to come hard. Means the energy is ready to transfer to the particular lattice ions. So no energy is ready to lose the electrons. This is simply energy can transfer. So these kind of lattice ions are ready to just vibrate or move in a particular direction. So the energy can transfer one place to another place. So electrons are ready to move in that. That's why. So the flow of obstructions will also be ready to present. How much of obstruction is ready to present? That is called as a resistance. For example, so here it is ready to this conductor is having some potentiality or some energy. So means it is having some resistance. It is ready to control the flow of charges. So then it should be called as a resistance. Yes. So which material contain that kind of resistance is called as a more resistance will applicable in a particular conductor, that is called as a resistor. So simply we can say one more definition is also resistance is nothing but how much of flow of electrons can obstruct by the conductor is called as a resistance, and resistor is a material. Which material can contain the resistance? So through it, that is called as a resistor. So then we will go for the different type of resistors and so things are there. Okay, in our daily life we can see that different type of people are having they getting electric shock, but some people they can die, some people they are not. So some people can get some effect, some people can lose their muscle controls and everything. So what is the difference between these different type of variations in a human bodies? The human body is a resistor or conductor. So the question arises in our mind. So for the answer of this question, we can go further. What is the human body contains the resistivity or resistance? Then the electric shock our body contains the resistance values. Means there is a inguinal power. So what we call that our right fingers are having a particular resistance that is a 100 ohms to 100 ohms to 5 lakhs ohms of resistance. Okay, so here it should be our human body contains the 100 ohms to 5 lakhs ohms of resistance. In between these values, we don't have proper idea depending on the body. So they may contain the 100 ohms to 5 lakhs ohms of resistance. So how to find out how much of electricity is passing through the particular human body? So then, if for example 24 volts of current is right to pass into a particular conductor, so 24 volts of current is right to enter to our human body. If for example the resistance of a human body and average 1000, okay, so 1000 ohms of resistance is there, then how much of electricity will enter into that particular body we can calculate. Then so we already know that V is equals to I into R. Say Ohm's law. From this Ohm's law, if I know that I is equals to V by R, then I want to find out that V is equals to, I is equals to V means what is that? 24 volts of current is directly passing through the R means there is a, resistance is a 1000. Then we can easily say that what is the value? 0.00 24 amperes of current is entered to our human body in this situation. So 24 volts of current and then 1000 ohms of resistance is there for the human body. Then that electric current is right to enter. I is equals to 0.0024 amperes of current entered in our human body. Then what can happen? So what will happen if, for example, 0.00, okay, so if the values are 0.001 amperes of current is right to enter our human body, what can happen in that? So in this situation, we will get that the feeling of electric current means we can feel it. So yes, this conductor containing electric current, we can feel it, that's it. So we don't have more than this. If for example, if our human body is getting that more than this one, 0.005 amperes of current, so in this situation, what can we identify? Means we is right to just get a painful. So that electricity is right to give us some pain. It's nothing but painful electricity we can identify. Then next one, 0.010 amperes of current is right to enter in our body. What will happen? So what is the things are right to appear? In this situation, we are right to get some. So what does it mean? Is it painful or sometimes? So we are right to lose a muscle control also. The next one, so we can go for it. .015 amperes of current. So it is a more serious than 0.010. So 0.015 amperes of current is right to enter into our body. Then we are right to get some more than this above values and we'll get loss of muscle control. Definitely we can, so loss the muscle control is a permanent damages there, so muscles. So then, so finally 0.07, okay, so 0.070 amperes of current is right to enter to our body. It is right to affect the heart. It should be affect to the heart, and in more than 1 second it is right to pass through our body. The person may die. Means it is a loss of controlling of our heart. It should be right to damage the heart directly. That's why it's the main important in our organs. The heart is the very most important organ. Then it's right to fail. The person may die. So that is the things we are right to observe in our daily life. So here the factors affecting the resistance. So different type of factors can affect on a resistance values. The resistance values can vary depending on the materials and some values are there. So first and main important is a temperature. The first one is a temperature. So temperature can increase, the resistance value may increase. So simply we can say that, for example, if I am going to say that if one conductor is there, the conductor resistance values are increasing. If in the possibility of the resistance is increasing, means definitely it should be increasing of a temperature. So both are proportionality. If a conductor increasing the temperature value, then as well as the resistance values can also be increased. So this is the proportionality. And the next one is next one and main important is nature of the material. So what is the meaning of the nature of the material means? For example, Ohm's law will explain that different type of materials contain their own resistance values. This is a fixed one. For example, iron has one resistance value and copper has their own resistance value, and so wood is also having their own resistance value. So each and every material contains their own resistance value. So that's why we can easily say that the second point can explain that the resistance will depend on the nature of the material. What is the material nature? So it should be depend on it. So this is the second one, and third one will explain that it is saying. So next one is the length of a conductor. So here we can explain the length. So length is nothing but if more length it contains the more resistance values. So both are proportionality. So length and resistance both are proportionality. If R is proportional to L, so L is a length, for example, the conductor length is a L. If increasing of a length, then as well as the resistance values may increase, and decreasing of a length, the resistance value will also be decreased. The next one is the fourth one is another one and important, then cross sectional area. For example, area. So if more cross sectional area, there is a decreasing of resistance value, means more increasing of cross sectional area, decreasing of resistance value. So both are inversely proportional together. So then R is proportional to 1 by A is inversely proportional to the cross sectional area. A is inversely proportional to the R is inversely proportional to the A. So if I take that R is proportional to L and R is proportional to L 1 by A, so if I combine these two, then R is proportional to L by A. So it is going to just observe that it is a R L by A. So if I remove a proportionality, then it should be called as a constant. That is R is equals to rho into L by A. So what does mean by rho? Rho is nothing but it is a resistivity. Resistivity means how much of resistance is like to present in a particular conductor is called as a resistivity. So I can explain that. First of all, I want to just show that as a rho is equals to, in this equation, RA divided by L will come. So this is a resistivity formula, and what is the unit of the resistivity means? That is a ohm meter. Okay, so ohm meter is the unit of resistivity. What is mean by resistivity? Now I can explain that. So resistivity is nothing but how much of percentage of obstruction will present in a conductor is called as the resistivity, and the reciprocal of a resistivity is called as a conductivity. So what does mean by reciprocal of conductivity? Reciprocal of resistivity is called as a conductivity means, for example, in a conductor, the 20% of resistivity is right to present means the 20% of obstruction is right to present means the remaining 80% is a conductivity. In a whole 100%, the 20% is the obstruction. The remaining 80% is a conduction. It is nothing but a conductivity. It is a resistivity and conductivity. So both the resistivity and conductivity is right to present. And depending on this resistivity and conductivity, for example, the temperature and as well as this resistivity, everything is right to depending on the material also. So these are the things are right to factors affecting on the resistance. Right? Circuits are the electric circuits is nothing but so where the battery is right to connect in a closed path, closed circuit. So in a closed path battery and as well as the resistance or anything you can just identify the bulb or anything you can consider or connecting a particular closed path, it should be called as a circuit. So electric circuits are there. We have the two types of electric circuits are there. One is a series connection and another one is a parallel connection of the electric circuits are there. So what is the use of the series connection and what is the use of the parallel connection? Means series connection is right to just appear that these are the resistance value. For example, if I know that it is a R1, R2, R3. These are three are the resistance are there, and here is the end-to-end connections will be ready to present. Means one is depending on another resistor, and so here you can go for it. It is a R1 and it is a R2 and it is a R3. So these two circuits are ready to connect to a battery. So here the R1 resistance, R2 and R3, these are end-to-end connections will ready to present. Means this is depending on it one to another. So this kind of connection is called as a series connection, and parallel connection means individual contact with a battery or no dependency with the others resistance is called as a parallel connections of the electric circuits. So in these two, the voltage is ready to appear as a different type of voltages. Means for example, in this area the voltage is a V1 and in this area the voltage is a V2. Means the potential values are vary from the one to others. But in this situation the potential values are constant but current values are ready to differ. It is a I1 and it is a I2 and it is a I3. So we have a different type of variations are there. In this series connection, the potential values are constant. Potential values are vary and current is the same. So it should be current is a constant. In this situation, in the parallel connection, the current is varies from the one to others, and the potential values are constant for each and every resistor. So in these equations, the series connection formula will explain that series. So series connection, directly I am going to write the formula that is saying individual R is equals to R1 plus R2 plus R3. For example, in this situation, three resistance are there in a series connection. The series connection will explain the result and final resultant resistance is nothing but R is equals to R1 plus R2 plus R3. In a parallel connection, what is the formula? So parallel connection 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So if I know that if I say third resistance is not there, it's a simplified equation. Means we can easily write R is equals to R1 R2 by R1 plus R. If I need to take as a R3 is a 0, no resistance will try to present in a third one. So third resistance is not there. Simplified equation R is equals to R1 R2 by R1 plus R2. So these are the series connection, parallel connection formulas and series and parallel connections of a particular conductor. Right? We'll explain that this is a Kirchoff law. So Kirchoff law is very very important. So depending on the Kirchoff law, we have the two types of laws are there in this Kirchoff law. So junction law is there and as well as loop law is there. In a particular conductor, in a circuit, so if we need to take as a junction, generally we know that what is meant by junction means, so different type of area people are ready to connect, are ready to come together and ready to go for the different type of areas. This is one meeting point, we can call it as a meeting point. Yes. Now the junction law will explain that. Say for example, this is a one explanation. If any circuit, the sum of the input currents are equal to the sum of the output currents, how much of current is ready to enter towards the center point is equals to that much of current is passing or going away from the point. So that's why, for example, I1, I2, I3, I4, I5. So five types of currents are there. Now, the towards the center point is nothing but I1 and I3 is towards the center point, I4 is a towards the center point. It's the sum of the input currents. Then equals to the sum of the output current. I2 is going away from the point, and so one more point is also there. Sorry, is a. Now if I am going to show it is a I5 is also moving away from the center point. Then once you see here, say I1 plus I3 plus I4 is equal. So sum of the input currents is equals to then I2 plus I5. So two types of, so 2 points of current is right to move away from the center point. This is sum of the input currents is equals to sum of the output current is the junction law. Then what about the loops law? So loops law is nothing but in a closed path, in a closed loop or closed path, the increasing or decreasing of the potential differences across the path, the loop must be zero. So what is the inner meaning or the total meaning? Means for example a circuit. So we have one is a bulb, one is a fan, or one is a, so TV is a different type of materials are there, different type of, so electric appliances are there. For example, the increasing or decreasing of a potential differences across the circuit, the loop must be zero. In this I will explain that. For example, the TV is ready to take as a, so 20 volts of electric current, for example, and so another is a fan is ready to take as a 5 volts of electric current or 5 volts of potential difference values of the means. So depending on the electrical appliances are containing their own potential values or their own voltage receiving values. That's why the increasing or decreasing of potential values across the circuit, the loop must be zero. It should be totally, it should be called as a zero. For that we have the sign conventions also there, how to identify the potential values across the circuit. So we can say that the sign conventions. So sign conventions. So here the sign conventions, the first one and second one I am going to draw. So very simple and very easy. So for example, if a battery is there is a big line is a positive and so small line is a negative, and this is a, so again one more drawing is there, same diagram, but small difference will be there. I will show it. So here if I am going to take as a resistance, here the resistance is right to present, and this is also resistance, but the directions of current is different. Okay, so towards the resistance is the I1, so now it is away from the resistance is a I1 here also. Okay, now the positive to negative and negative to positive in this situation, this is helpful for this one, and this is, now I will explain that if I am going to take as a battery in the circuit, the positive to negative direction, if you want to take as a, the potential values must be negative. So simple, just keep in your mind, if battery will shows like this, a positive and negative, the flow of potential or the flow of current, so in a to the particular battery means positive to negative means the resultant value is a negative. Okay, now what about the towards the resistance, the electricity is right to conduct, so then it should be also having negative. So towards the resistance is called as a negative, and so positive to negative the battery is also having negative signs. Then if I this is total is opposite, means there is a negative to positive, the flow of potential values or flow of electric current values are there, means then we can call it as a positive, and then so away from the resistance we are ready to call as a positive. So both are in a positive situation. These are the sign conventions. Again I am going to explain. See here, the plus to minus is the potential values are negative, and here the negative to positive, minus to plus, it should be positive. Then towards the resistance is a negative, away from the resistance is a positive. These are the sign conventions what we have. For example, I want to show one example to you. In this example, once you see here, so A, B, C, D, E, A is the closed path or closed circuit is there. Now, if I want to explain that A, B, C, D, E, A is a closed path, I want to explain that what is the potential values towards this one, is a negative or positive by using all these sign conventions. What I said that A, B. A to B is a positive to negative. The direction of a potential values are positive to negative. So V1 is a negative because of the reason positive to negative is a negative. And next one, after completion of this one, if you go for this one, you should not consider this one. So then the resistance is moving, for example, electric current is moving away from the resistance. That's why it should be away from the resistance. It's a positive. Then we go for it. Z positive. The potential values V is equals to I into R. That's why the I1 R1 is a loop must be 0. So this is a simple formula. You can write it minus V1 plus I1 R1 is equals to 0. So this is the value of the particular circuit by using of a loop law. So in this loop law, after completion of this loop law, we have a different type of examples are there. You can practice more. So circuits, electric circuit by using of a loop law, you can get more ideas on it. Okay, to go for it is a power. So electricity can calculate any powers only. It is nothing but how much of electricity we can use in our daily life. So each and everything is depending on a electric power. So how to calculate the power means we already know that if any the work is nothing but the W is equals to work is equals to the charge is a Q is multiplied with potential V. So W is equals to Q into V is a one formula to find out the work values in a particular electric conductor. So W is equals to Q into V. So in this both side I can apply the T values. I am going to divide the T values both side. The QV divided by T is also both side I can apply. So what is meant by the work per time? How much of work we did by using of a particular instance of time? It's nothing but it is a power is a P. The P is equals to, now we know that is a Q by T is having a special formula for it. So Q by T is nothing but electric current is nothing but I is equals to Q by T. So we already know this one. Then from this equation I am going to write the P is equals to I into V. Or otherwise, so one more formula is also that V is equals to I into R. Then we go for it is the P is equals to I into R. So what is that? P is equals to I square into R. And we go for it one more formula is also there, I is equals to V by R also. By using of the Ohms law only. Then if I substitute the one more value in this equation, the P is equals to, what is the I means? There is a P by R. So whole square into R. Then if I write the P is equals to P square by R square into R. The R will get cancelled and one more R will be there. The V square by R will be there. These are all our formulas by using of power values. The P is equals to I square into R and P is equals to I into V and P is equals to V square by R. So in these three formulas, if you know any two values, then we can easily find out the third value. If they given as a potential and resistance, we can easily find out how much of power it is. And the power should be calculated in a watts. Mainly the power should be calculated in a watt. Okay. 1 kilowatt is equals to 1000 watts. So kilo means is 1000. 1 kilowatt is equals to 1000 watts. In our daily life, units also there. For example, electricity is calculated in units nowadays. If you go for any electric consumption, if I need to just calculate the electric consumptions are there, means the electric consumptions are ready to depending on the units. How many units are ready to present in our daily life? How many units of electricity we can use it. So that's why I am going to say that one more value is also there. Here I am going to write 1 unit is equals to 1 kWh. What is meant by kWh? Kilowatt per hour is nothing but is a 3.6 into 10 to the power of 6 joules of electricity. Okay. So now, this is only joules only. 3.6 into 10 to the power of 6 joules of energy we are using. So there is a 1 kWh or otherwise 1 unit of electric current. In our daily life, we are trying to calculate by electricity by using of this one only. Right? Now we go for it is a overloading. Overloading is nothing but in our electrical appliances. In our home, we are using the different type of electrical appliances. For example, in my home, I am using the fan, TV, fridge, so tube light or different type of electrical appliances are there. So in these appliances, what is mean by overloading in this particular circuit? So simply overloading is nothing but if at a time we are using all electrical appliances, if the particular voltage, or for example in our homes we are going to get that, so 24 amperes of current or 24 volts of electric supply is right to present. So we have a different type of fan, fridge, TV and different type of things are right to present. So each and every what does it mean? Each and every TV and fridge and whatever it may be, fan, heater can apply or can receiving the different type of, for example in our home we have 20 amperes of current. I am using the 20 amperes of current. The fan is using, so TV is using 6 amperes of current, and as well as, so next one the TV is completed, and next one the fridge is using as a, so 8 amperes of current. Okay, so the next one if I take as a bulb is a 2 amperes of current. So once you observe that the fan is also there is also 4 amperes of current. Once you calculate the 6 plus 8 plus 2 plus 4, the overall 20 amperes of electricity completed. Then no electricity is right to apply to remaining applications or remaining electrical appliances. For example, if I need to use one more, there is a heater. Okay, the heater I am going to use. So no electricity or no current values are present. This is called as overloading. So compared to the appliances, the more appliances are right to apply in a proper or in a specified electric circuit, that is called as overloading. So to prevent the overloading, we are using the fuse. Fuse is the main important to protect our electric appliances by using of this kind of overloading. By applying of a overloading, we can use the fuse. So what is the fuse mechanism in our appliances means? The fuse is a thin wire containing in it. So it is a low melting point. So if any electricity, high electricity is like to enter in a particular electric current, more than the 20 amperes of current, then automatically the thin wire has a low melting point. That's why it's ready to melt and it detach the cable, and then it should become as a open circuit. So then we can call that yes, that all electrical appliances are protected by using of this kind of fuse. See, to protect the appliances by using of a fuse only, it's nothing but overloading. Overloading can be protected by using of a fuse. So these are the things that will appear in our daily life. We can easy to protect